How's it going, everybody? This video is going to be a walkthrough of the study guide for our Congruence and Transformations chapters 8 and 9. This video is meant for you to check your work, mainly for people who can't come to study hall. So if you haven't done this yet, please try it on your own. Stop the video, try to do the problems on your own. And if you get stuck and can't come to study hall, then come check your work here. This video might be kind of long, so you're free to fast forward to whatever part you want to see. But let's get into it. So number one, we need to find the graph that shows a reflection over the x-axis. So that would be D. Remember, reflections, take 1 point from the pre-image, see how far it is from the line of reflection, and go that same distance on the opposite side of the line to get your new point. So like this point here is 3 away from the line. If I go 3 away from the line in the opposite direction, I'd have a point there. Number two, graph the figure and its image. So right off the bat, it can't be C, it can't be D, because it only shows a figure, either the pre-image or the image, but it doesn't show both. So it's got to be A or B, and we want to see the graph that has line segment AB with these endpoints. And then the image, A prime, B prime, is going to be the result you get after reflecting across the y-axis. So these pictures look almost the same. It's just that AB is in the correct spot here. In B, the pre-image and the image and the pre-image are reversed. So AB should not be here. That should be A prime, B prime, like it is here. So it's A. Number three, so just to preface this, I have a red rectangle here. That's probably where it should be if it was actually rotated about point Q. So just ignore the about point Q for a moment. When it says rotate the parallelogram 90 degrees clockwise, the main thing I'm checking for in this question is that you can see parallelogram ABCD has side AB on the left, right? So you should be able to visualize that if I were to rotate this shape 90 degrees clockwise, then AB is going to be, or I guess A prime, B prime, the image of AB, will end up being at the top of our drawing. And the only choice that has that, AB up here, is choice A. See, AB's over here. That doesn't work. That would be like a 180 degree rotation. Again, that's a 180 degree rotation. This would be like 90 degrees clockwise. I'm sorry, 90 degrees counterclockwise, or 270 degrees clockwise. So it would be A. The reason I have this red rectangle here is because that's actually where it would be if it was rotated about point Q. So the way you can tell is I should be able to pick any pair of corresponding points, like A and A prime. And if I were to draw lines to the point of rotation, it should make that degree angle, a 90 degree angle, and that's not a 90 degree angle. In fact, it's even worse if you pair D and D prime, that's like 180 degrees. So really it should be here with A prime, B prime, and so on. But again, ignore the point of rotation, just pick which one shows a 90 degree clockwise rotation. Same thing for for number 4 here. 90 degrees, but it says counterclockwise, so we're now rotating this way. And in that case, the answer would be B. Again, like AB is on the left, and after we rotate it 90 degrees counterclockwise, A prime, B prime will end up being on the bottom. Number 5, which pair of triangles is congruent by angle side angle? So we need both triangles to have a matching pair of angles, another matching pair of angles, and a matching pair of sides, and those sides have to be the connecting sides or the included sides. So notice in choice D, this side is between the two angles, and so is this side. You might be fooled by A. Make sure you check both triangles. Even though this triangle looks like it's angle side angle, the second triangle is not. That's angle angle side. And then it can't be C because that has 2 sides and we only need 1. Same thing, it can't be B because it has 2 sides and we only need 1. Number 6, we have a diagram here. What postulate or theorem lets us immediately conclude that the two triangles are congruent? Well, we have one pair of angles, we have another pair of angles, and then it's not given in the picture, but we should notice right away that both triangles share side BD. So that's the reflexive property. Technically the reflexive property of line segment congruence. So we can say BD is congruent to itself. And in that case, we have two angles and the side that's not connecting them. So angle, angle, side, not angle, side, angle. And definitely not side, angle, side, because we only have one side on each triangle. All right, number 7, if you get a picture, but it's not labeled and it just gives you information in words, you need to label it. So angle A is congruent to angle D. I marked that with one arc on each triangle. Angle C is congruent to angle F. I marked that with 2 arcs on each triangle to show that they're different from A and D. What if we were given one more piece of information? It could be any of these 4 things. Which piece of information does not allow us to conclude that the triangles are congruent? Let's just check each one. If it were A, BC is congruent to EF. Well, then we would have angle, angle, side. And angle, angle, side does prove congruence. So we're looking for which does not prove congruence. So it can't be A. If we check B, that's going to be our answer. Angle B, if we knew that was congruent to angle E, I guess I could mark it with 3 tick marks. That's angle, angle, angle. And angle, angle, angle does not prove congruence. If you check C or D, you'll end up with something like that or something like this. And both of those prove congruence. You'd either have angle, angle, side or angle, side, angle. Those both prove congruence. All right, the matching, that's a practice in vocabulary, really. If you miss these, check your notes. Go back to your notes in 9.1? Oh, my bad, 9.2. Check your notes on 9.2. We go over all of these. Number 13. Can you use the side angle side postulate, the angle angle side theorem, or both? So, when you have a picture like this, you should notice we have 2 lines that are intersecting, so we have vertical angles that we can use. But even with that, we only know one side of the left triangle is congruent to one side of the right triangle. We definitely don't have 2 sides, so we can't use side angle side. However, as long as you remember your vertical angles, we do have angle angle side, angle angle side, so we can use angle angle side to prove that those 2 triangles are congruent. All right, for 14 and 15, we are given a pre-image, or before picture, and an image or after picture. And we just want to match up corresponding points. So what's the image of F? Well, F is the point in the pre-image, and it seems like it's the biggest angle. It's definitely an obtuse angle. So the obtuse angle in the image is angle S. Then it asks us for the image of side FC, which is the shortest side of the before picture. So the after picture has the shortest side labeled ST. So we're going to say the image of FC is ST. And order does matter here. F was that obtuse angle and so is S. So it's more proper for you to say ST here instead of TS. All right, number 16, we're given triangle ABC. Be careful with how it's scaled. A is at the point 0, 3 because each box is scaled by 2s, right? Because that's how we get 2, 4, 6, 8, and -2, -4, -6, -8. So I didn't write out the coordinates here, but you should know that this capital T and then the subscript -5, 2, it means we're going to translate, T for translate, and -5 means subtract 5 from the x coordinate. In other words, move each point left 5. And 2 means add 2 to the y coordinate, or move each point up 2. So if I take A and I move it left 5 and up 2, there's A prime. If I take B, oh, sorry, this is C. If I take C and move it left 5 and up 2, that would put me here. If I take B, move it left 5 and up 2, that would put me right there. And there's my image, A prime, B prime, C prime. I know it says which graph on the test. It might be multiple choice, but I just gave you a blank graph here. I want you to translate it yourself. All right, for the next few questions, we're going to use this diagram, so you might have to flip pages. But for 17, what's the image of C under the translation T 4, 5? So if I take C and I move it 4 units to the right, because it's a positive 4, and 5 units up, because it's a positive 5, I will end up at point E. Again, watch out for how the graph is scaled. It doesn't mean move 4 boxes, because each box is actually 2 units. Number 18 says find the translation that describes moving B to E. So point B is here, point E is up here. If you count how far we have to move up, we don't actually move left or right because they both have the same x coordinate, but we have to move up 15 from B to get to E. So the translation would look like this. You could write it as an algebraic rule, or you could write it using this shorthand notation T and then subscript 0, 15. Number 19 gives us the vertices of a rectangle, R, S, T, and U. And we're going to translate R to this point. This is a little tricky, but what's the translation? Well, R is actually -5, -5. So if that point gets moved to -4, 2, we need to find out what are we adding to -5, the original x coordinate, to get -4, the new x coordinate, and we'd have to add 1. Similarly, what do we add to the original y coordinate to get the new y coordinate? Well, we have to add to -5 to get +2. Well, we have to add 7. So the translation is adding 1 to the x coordinate and adding 7 to the y coordinate. You could write it shorthand this way. If you prefer, you can write it in algebraic form, but I just wrote it T 1, 7. But then the question also has a second part. Find the translation rule. We did that. And the image of U. So U is this point here, -5, 1. And I'm going to add 1 to the x coordinate, add 7 to the y coordinate. So the image of U is going to be -4, 8. Number 20, describe in words the translation of x represented by the translation rule 3, 8 of x. So again, you should be able to tell me that this 3 means move right 3, this 8 means move up 8. Number 21, the translation rule to describe the translation of x, that is 5 units to the left and 1 unit up. This is pretty much number 20, but backwards. 5 units to the left means I need a -5 here. 1 unit up means I need a +1 here. Number 22, a carnival ride is drawn on a coordinate plane so that the first car is located at the point 30, 0. What are the coordinates of the first car after a rotation of 270 degrees about the origin? I am not requiring you to memorize these rules. You should have this on a note card. You should know that a rotation 270 degrees about the origin, that means 270 degrees counterclockwise, can be modeled by this rule here. xy goes to y, -x. So x is 30. That means that we'll have a -30 as our new y coordinate. 0 is our y. So 0 is going to be the new x coordinate. So 30, 0 is going to go to 0, -30. And that would rotate at 270 degrees about the origin. Number 23, name the image of J under a reflection in line M. So where's line M? It's right here. That's what this little lowercase m is there for. And so if we take point J, which is right here, we need to find out how far is it from line M. And what I mean is the shortest distance from J to M, it's going to be that perpendicular distance right here. And if I go that same distance in the opposite direction, that'll land us at point L. Number 24, find the scale factor. So Remember, scale factor is the image length divided by the pre-image length. So be very careful here. Sometimes people confuse which one's the image, which one's the pre-image. The pre-image is your before. That's your A, B, C, D. So this length of 3 from D to C is a pre-image length that goes in the denominator. The image is our after shape, so it's labeled with primes. So A prime, B prime, C prime, D prime has a corresponding length from D prime to C prime of 6. So 6 needs to be in the numerator, and when we reduce this fraction, we get 2. So our scale factor is 2. We multiplied all the lengths in the pre-image by 2 to get the lengths in the image. 25, solve for x. The figure is not drawn to scale. Check it out. We have vertical angles. We know that vertical angles must be congruent. So if they tell us that the measure of angle 1, this angle here, is 4x minus 80 degrees, and the measure of angle 2 is 6x minus 40 degrees, and they're both vertical angles, that means these have to be equal. So we're going to say 4x minus 80 equals 6x minus 40. We've solved linear equations plenty of times ever since the beginning of last semester. Whatever you do to one side of the equation, you have to do to the other. So if I take this 4x minus 80 and I subtract 4x and add 40 to the left side, that's okay, as long as I do the same thing to the right side. Subtract 4x, add 40. When I combine my like terms, this makes a 0. Negative 80 plus 40 is negative 40. 6x minus 2x, or minus 4x is 2x. And then negative 40 plus 40 is just 0. So we're left with this equation, which is much nicer. If we divide both sides by 2, we'll get x by itself on the right side. It means x has to equal negative 20. All right, 26. We have, it's given that AOC is a right angle, AOC. So I drew that right here to show that it's 90 degrees. And they tell us that AOB, angle AOB, is 74 degrees. So that means BOC, the angle we're trying to find, it's going to be however many degrees we need, so that 74 plus whatever number we're trying to find adds up to 90. So the measure of angle BOC plus 74 needs to equal 90. If we subtract 74 from both sides, we'll find that the angle we're looking for needs to be 16 degrees because they are complementary. All right, this one's very similar, except AOC doesn't add to 90, it's 180 degrees. So 144 plus something needs to equal 180 degrees. So in other words, measure of angle BOC plus 144 equals 180. Subtract 144 from both sides and we'll find that this angle needs to be 36 degrees. Number 28, we have LON is a straight angle, or it's 180 degrees. And they tell us that LOM, this angle here, is 4x plus 102. And MON, the bigger angle here, is 6x plus 138 degrees. And we need to find, careful. It doesn't say find x. So a lot of people will stop when they get to x equals negative 6. But it doesn't say find x. It says find the measure of angle MON. So we need to take our answer. If x is negative 6, plug that in right here for x. 6 times negative 6 plus 138, we need to find out what that is. It's actually comes out to be 102. So the measure of angle MON is 102 degrees. Number 29, find the value of x. So this one is just saying find x. We know that line L and line M are parallel, and we have a transverse line going through them. So 4x and 80 degrees are both in the upper left corner of their intersections, right? So upper left corner, upper left corner. Those are corresponding angles, which we know have to be congruent. So we set them, their measures equal to each other. 4x has to equal 80, which means x is 20. Number 30, line L is parallel to line T. Find the measure of angle 6. So we have, line R. Line R and line T are parallel. Angle 6 is down here. But all we know is that this angle up here is 136 degrees. So we could start by saying that the measure of angle 2 is congruent to this angle. So angle 2 has to be 136 degrees. And then angle 2 and 6, well, aren't they supplementary? Because they make a straight angle, right? So the measure of angle 6, the angle we're looking for, plus that 136 degrees from angle 2 needs to equal 180. And we solve that for the measure of angle 6, and we should find that it's 44 degrees. Number 31, what's the measure of angle G? Again, we have parallel lines. So if this is 25, then so is this. And then this angle here is a vertical angle with angle G. So vertical angles are also congruent. Angle G has to be 25 as well. Number 32, parallel lines in a transversal. Find the value of x for which L is parallel to M. So actually, we aren't told that these are parallel. We need to find out what value of x would make them parallel. And we're relying on the fact that, well, if they are parallel, then alternate interior angles need to be congruent. So we can still set 3x minus 43 equal to the measure of its alternate interior angle, 80. Solve for x, and we'll find that x is 41. So what we're saying is that if x is 41, then we can conclude that the lines L and M would have to be parallel, because alternate interior angles would be congruent. Number 33, find the value of k. Remember, the three angles in a triangle always add up to 180. So 33 plus 75 plus k has to equal 180. Combine your like terms. 33 plus 75 is 108. And if you subtract 108 from both sides, you'll get that k is 72. Number 34, find the values of x, y, and z. The diagram is not drawn to scale. So I'm hoping you can, visualize this blue triangle, this green triangle, and then the whole thing as well. Starting with the blue triangle, we know two of its three angles, and those three angles have to add up to 180. So similar to the last problem, we can solve for x. We'll get that x is 76. We're actually going to find z next, because x and z make a straight angle, so they have to add up to 180. But we know x is 76, so if we subtract 76 from both sides, we'll find that z has to be 104. And then finally, this green triangle, originally we only knew one angle, but now that we know z, we have two angles in the green triangle. So if we add that to the third angle, the one we don't know, y, those three angles also have to add up to 180. Plug in your 104, because we know what z is. Combine your like terms. 13 plus 104 is 117. Subtract 117 from both sides, and we have y equals 63. So now we found x, y, and z. Number 35, find the value of x. The diagram is not drawn to scale. Well, we have vertical angles again. They have to be congruent. And then in the triangle, the three angles add up to 180. So x plus 110 plus 57 is 180. Combine your like terms. Subtract 167 from both sides, and we'll get x has to be 13. All right, so number 36. That's this graph here, and it tells us that triangle ABC is reflected across the line y equals -2. And so I drew that line here as a red dotted line, y equals -2. And it's asking, would the new triangle A prime, B prime, C prime, be congruent to triangle ABC? Well, yes, it would, because reflections, we learned, are rigid transformations, and so are translations or rotations. And all of them, you can combine, do multiple transformations, multiple reflections, translations, or rotations, And your end result will still be congruent. So yes, they will be congruent. But then it asks, what would the coordinates be for our image? So that's why I drew the line, because we don't have a rule for reflecting over y equals -2. But we can look at the point B and say, well, it is 0 units away from my line of reflection. So B prime also needs to be 0 units away. It's going to be the same point. A, on the other hand, is 1, 2, 3 units away from the line of reflection. So we're going to go 3 units away in the opposite direction, and that'll be A prime. And its coordinates are going to be 2, -5. And then C is down here. It's 1 unit away from the line of reflection, so C prime will be 1 unit away in the opposite direction. So C prime will be at -3, -1. All right, number 37. It says, name the transformation that mapped triangle ABC to triangle A prime, B prime, C prime. So we're given our pre-image and our image, and we should be able to just look at the picture and already kind of guess what transformation it might be. If it was a translation or a slide, then the orientation of this triangle would stay the same, and we'd have something else that, pointed the same way, and we don't, right? Because our right angle is now down here instead of up here. So it's not a translation. It could be a reflection. It could be a rotation. To really see what it is, I recommend you write down the coordinates. Write down the coordinates for A and A prime and show how A goes to A prime. And then do the same thing for B and B prime. And then do the same thing for C and C prime. And then let's see if we can find a pattern with the coordinates. I'm hoping you notice that the X coordinates of our pre-image and the Y coordinates of our image look very similar. The only difference is all of these Y coordinates of the image, they are the opposite of these X coordinates in the pre-image. So in other words, we're taking whatever the X coordinate is, finding the opposite of that number, and that's our new Y coordinate. And we have a similar pattern for the Y coordinate of the pre-image, or our starting Y coordinate, and our after transformation X coordinates, right? 4 goes to -4, 4 goes to -4, 2 goes to -2. So we can generalize this and say that the point XY is being sent to the point -y, -x. You should have this in your notes. Definitely put it on a note card for test day. This rule is a reflection over the line y equals -x. If you don't remember that, that's okay. Just refer back to your notes. It should be in lesson 8.2, reflections. So the line y equals -x looks like this. And sure enough, it is a reflection because A is going to be so far away from the line. A prime is there. B is so far away from the line, it gets sent there. Same for C, it gets sent to C prime. Definitely a reflection. Number 38. Given that triangle QRS is congruent to triangle TUV, and they tell us a value for the length of QS and the length of TV, find the length of those line segments. Well, there's no picture, so it's a good idea to draw one. QRS, TUV, they're not drawn to scale, but that's okay. We know that the triangles are congruent, and corresponding parts of congruent triangles are congruent. QS, that's the first letter and the last letter in this triangle. And TV, well, that's also the first letter and the last letter of this triangle. So they have to be congruent because they're congruent parts of congruent triangles, which means their lengths are the same. So we can set this length equal to this length. I do that here, and then solve the equation for the letter V, the variable. So I did the same thing to both sides. I subtracted 3V and added 6 to the left side of the equal sign, and I also did it to the right side of the equal sign. I'm left with 8 equals 4V when I combine my like terms. And then if I divide both sides by 4, I find that V is 2. Again, I highlighted the question. It's not asking us to solve for v, but we need v to get our answer. To find the length of QS and TV, I plug that value in. V is 2. And so it doesn't matter which one you plug it into because they will be the same. They're congruent, right? 3 times 2 plus 2, that's what I did here. I should get 8. But even if I said this V is 2, then 7 times 2 is 14, minus 6 is still 8. So QS and TV both have a length of 8. 39. The two triangles are congruent, as suggested by their appearance. So I am really just testing you to see if you can tell corresponding parts. If I ask you what's the value of G, well, G is here. G is this length. So since the triangles are congruent and the corresponding length on this triangle is 17, that means G is 17. 40, we have a picture and we have some given bits of information. They were not, were they marked already? No, they were not. So mark it on your picture. If we know that RS is congruent to UT, mark it. We also know that RT is congruent to US, so we mark that. So we have two pairs, one pair of sides that are congruent and another pair of sides that are congruent. That's line 1 and line 2. Line 3, how can we say that? How can we say that ST is congruent to TS? Well, it's the same line segment, so we know that by the reflexive property. So this has to be congruent to itself, and then we have a triangle with 3 congruent sides, and another triangle, 3 congruent sides. So the triangles are congruent by side, side, side. 41, we have our picture here. What other information do we need to prove that the triangles are congruent using side, angle, side? Well, we have one pair of sides already. That's the blue S I highlighted. And then we actually have a second pair of congruent sides because of the reflexive property. AC, line segment AC, is congruent to itself in either triangle. If we want side, angle, side, we need the angle in between to match the other angle in between. So we need to know that angle BCA is congruent to angle DCA. And if we have that, then the triangles would be congruent by side, angle, side. Number 42, which triangles are congruent by angle, side, angle? It would be these two, because we have angle, side, angle. This one has angle, side, side, and that doesn't prove congruence. 43. Can we prove that the triangles are congruent? Yes. Don't be fooled. This looks like angle, 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 right? And we know that angle, angle, angle does not prove congruence. But we do have this hidden side length here. DF is a side length of the left triangle. It's also a side length of the right triangle, and by the reflexive property, it has to be congruent to itself. So use that side length and any two pairs of angles you want, and you'll end up with the triangles being congruent either by angle, side, angle, or angle, angle, side, depending on if you pick the two angles that have DF as the included angle, or maybe you pick two angles that DF is not the connecting angle, or the connecting side. 44. The triangle is isosceles, so we know not only that the two sides are 21, the two sides have to be the same length, but the base angles have to be congruent. So if this angle has a degree of x, then so does the other base angle. So we have x plus 38 adds up to 180, because the three angles in a triangle have a sum of 180. Combine your like terms and then solve for x. We should get that x is 71. Number 45, very similar. We have a triangle. If this base angle is 56, then so is this, because it's isosceles. Add up the three angles of the triangle, they should equal 180, and we'll find that x is 68. Number 46, find the values of x and y. So x is here, y is here. This blue part explains why we got 90. AD, it bisects the vertex angle because these are congruent, right? So we learned about the vertex angle bisector theorem, and it means that BD and DC are congruent. It also means that AD crosses BC at a 90-degree angle, they're perpendicular. So X has to be 90. And the green part, well, that angle's 46, so is this angle here, because they are base angles of triangle ABC. And then we can use that to find Y, because the three angles in this triangle add up to 180. So I've got that. Y is 44. And that is the end of the study guide for chapters 8 and 9. If you have any questions, please reach out.